Hi, my name is Michael Webb with CIM System USA. We are an Italian-based software developer and we make CAM software. And what I'd like to show you guys today is a new interface that we've been developing for our current Sum3D CAM users. So this is Mailbox. Mailbox is basically a new interface to our Sum3D CAM software. Sum3D is still running as an engine in the background, so we still have all the same features and all the same complexity or tool paths that are offered in Sum3D, but we have this new cool interface to offer them. So basically what we have over here is our workflow from the top to the bottom. We start always with a new project, we import our items for milling, and then we select our materials, and then we start the milling process. We can also do simulations. Over here on the left side of the screen, we have the ability to open previous projects, some tools that allow us to either do operations like auto nesting, showing equipment, checking out our reusable stock library, things of those sorts, as well as a new undo and a redo button. And then down here in the bottom left-hand corner, we just have information that pertains to the job that we're working on as we're going through the process. So basically, I've clicked on the new project, and we've got a little pop out here on the right-hand side of the screen. What we've done that's different now in Mailbox from the traditional Sum3D is as we click on each object or each machine, we only see the materials that apply for that particular machine. So before we used to have just one material list for all machines. So in order to eliminate any issues like trying to run titanium on a small desktop mill that's a dry mill, we've kind of segregated that out. So simply select the machine and select the material, and we're going to select the equipment, whether we're using blocks or pins, and or we can use a disc. So in this case we'll use a disc, and it automatically takes us down to this next step, which is the Importar Sdls. So here we have a list of STL files that I've been working with. We'll open up some crowns here, and when I click on the STL file, we get a big preview up here, right above here, and when I click on this preview, I get another window that I can actually rotate and do some QA on the STL before I'm going to mill it. Maybe try and check and see if there's any issues in the CAD software. But you can go through here and simply select the STL and select the object type, which is a crown, and then go down here to import selected file, and it automatically imports that into the job. We can see it's back here in the background, but as it's there, I can go ahead and select other crowns for this case and bring all those in as well. So once I have all my STLs selected and imported, I can just click the little checkbox in the bottom right hand corner, and it takes me to the next step, which is the materials. So here I have a list of my materials. In this case it's zirconia because that's the material I chose, and I have different varying thicknesses for that material. So if we actually were to nest something in the 10mm disc, we can see here visually on the screen that this is not going to fit because we have a little red indicator on the enclosed surface basically stating that that piece of the part is outside of the disc. So we automatically know we need to choose a larger selection, maybe a 14mm disc in this instance. So I'll just simply click check, and because it's zirconia, it's going to ask me for a scaling factor. So I enter in my disc specific scaling factor, and what it's going to do now is automatically nest these objects and place the support pins within the disc. So this is a lot quicker than our previous solution with just regular Sum3D. The engine's much faster, the 3D rendering is much better. We've improved a lot of different things with the software. What we can also do now at this point, if we want to quickly edit our support pins, I can just grab it and move the support pin wherever I want. The color coding here, basically we have red, green, and blue connectors. The red means that it's going to reduce it down by half the diameter, green is going to completely remove the connector, and blue is going to leave the connector completely uncut or not even mill it out. So basically that allows us flexibility. As we're milling, these connectors are going to stay there, but after the milling process is completed, we can trim these away to help aid in the process of removal from the disc. So what I can also do is I can select the STL files and move those directly. Say if I wanted to do a part-to-part connector, all I have to do is simply move those two boundaries to connect to one another, and that helps me link up STL files. I can also rotate these STL files directly as I'm nesting. And let's say that I decide not to use this support pin anymore, I can just select it and hit delete on my keyboard to get rid of that. So one of the other things that we also have at this point, let's say I'm done nesting, what I would go ahead and do is hit start mill, and this would calculate. I'd have a file that I can send out to my mill. In this particular instance, what I'm also going to show you guys is the multi-layered stock that we're going to be working on. With a lot of the new multi-layered stock from Katana, and some of the others like Sage Max, we're integrating the ability or the visual of that multi-shaded disc into the CAM software. So again, I'm just going to bring in another crown here, do an anterior restoration. And for my material, we have it pre-programmed for PMMA, but in the future we'll also have other zirconia materials supported as well. So in this case, now that I have my restoration, I can clearly see the difference in shades here. I can adjust my cusp tips, change the angle of the part, and I can also move it up or down to move it between layers. So these are some of the new integrations that we have with the new mailbox, and this is what users will have to look forward to in the new CAM software.